Good evening, students. Our today's lesson is about rational and irrational numbers, and I will try my best to explain it in detail so that all of you can get the concept in a proper way. Okay, so basically my focus is on the exercise 2.1, and the first question of this exercise is identify rational and irrational numbers. So before we go into detail of the question, let's try our best to understand the definition of rational numbers and irrational numbers. So rational numbers, like for example, any number x by definition, rational numbers by definition, any number x which can be represented, that x can be written as p over q, like in simple words, it's a fraction where p is numerator, q is denominator. So p and q, we can replace this comma with this sign, and p and q, they both belong to set of integer, and q is not equal to 0. Means, like you know that in set of integer all numbers come, all negative number, positive number, and 0 is also included. So denominator, it's a condition on denominator that denominator cannot be equal to 0. P may be 0, it may or may not be, but this q cannot be. So all numbers which can be written in the form of p over q are called rational numbers. So examples are like 1 over 2, 22 over 7, square root 1, square root 16. These numbers, they are having their own concept. Like if we understand their concept, then we will know that why do we call them rational numbers. But I will go in detail of this thing in upcoming questions. Irrational number. Rational numbers are denoted by q, capital Q. Irrational numbers are denoted by q dash upon q. And what are irrational numbers? Rational numbers are those numbers, any number x, such that x is not equal to p over q. Like all those numbers which cannot be written in the form of p over q or in the form of fraction, then those numbers are called, this thing is same as in rational numbers. So all those numbers are called irrational numbers. So square root 2, square root 3, pi, this number which is denoted by e, its value is, it's basically a symbol, and its value is I hope so 2.718, like this. So pi, you all know, this is 3.142, and sometimes it is taken as 22 over 7. But why pi is irrational? This question arises. Why pi is irrational and 22 over 7 is rational? Okay, always remember that 22 over 7 is approximately equal to this pi. Basically pi is having its own definition, and this is just a crude approximation, or in simple words you can say general approximation, or if we make it more simple, then we can call it rough approximation. Not exactly, this pi 22 over 7 is not exactly equal to pi. So pi itself is irrational, but 22 over 7, because it is according to the definition of the rational number, so that's why we call it rational number, because rational numbers are those numbers which are written as in the form of p over q. Why this square root 1 and square root 16, why these are called rational numbers? So remember that if there is a square root sign on perfect square, you know 1 is a perfect square of 1 and 16 is a perfect square of 4. So when square root is upon any perfect square that is having exact answer, like the square root of 16 is equal to 4, square root 1 is equal to 1, you know. So all perfect squares with square root are rational, but all those numbers which are not perfect square, like you know that 2 is not a perfect square, 3 is not a perfect square, square root 5, 7 you know is not a perfect square, and if the square root is upon it, then these all are examples of irrational numbers. So I hope so that the definition of rational number and irrational number is clear. And 1 over 2, you know, it if we convert it into decimal form, it is 0.5. So later on we will also discuss that decimals are also of they are all of two types. So I will also discuss that those two types as well. So let's now move towards our question. Question number 1 was that identify, some parts are given of this question and we have to identify that are those rational numbers or irrational. So parts are yes. First part is square root 3. Second part is 1 over 6. Third part is pi. Fourth part is 15 over 2. Fifth part is 7.25, and last part, which is sixth, is square root 29. So according to the definition which I have told you, I would suggest that you should also try by yourself first, then I will write their answers. So I hope so that you have done it. You know that this square root 3 is not a perfect square and square root is upon not a perfect square number, so that's why it is irrational. Irrational, irrational. 1 over 6 is exactly according to the definition of rational number, so that's why it is rational number. Pi, I told you that it is irrational, and 15 over 2, again it is according to the definition of the rational number, so it is rational. 7.25, I explain it. Sixth, square root 29 is not a perfect square, so it is irrational. Now 7.25, why it is rational? Decimal, it is a decimal number. Now decimal numbers are further, they are categorized into two parts or into two types: terminating decimals, like this number 7.25, it is having two decimal place, and there is no recurring, it is not recurring, like it is not repeating itself, no block, no same number is repeating itself, so that's why it is terminating decimal, like 1.5, 2.67557, etc. All these type of the examples in which the number after decimal they stop, they are not repeating, and they are also, you can say, defined numbers. So these type of the numbers are called terminating decimals. Okay, non-terminating decimals means those numbers which after decimal repeat, after decimal they are not actually stopping. Okay, so those are called not terminating decimals. So and recurring decimals. Recurring decimals are those numbers like if we write 1.5555 so on, and the other number is 2.657657 so on. These type of the numbers are called recurring decimals. Why? Because in this example you can see that 5 is repeating itself. Okay, it is coming again and again and this will never finish. So this is also called non-terminating, because terminating 1.5 terminated, but it is not terminating or non-terminating. In the same way this is non-terminating, so that's why it is called recurring. But why recurring? Because you can see that here we have a block is 657, and after that we will again get 657. So it's a block. So whenever we get a block, then we use a line on it. Like for example, if I write it 1.5, I will use a bar on 5. This bar tells me that 5 is repeating itself continuously, it is not stopping. In the same way 2.657, we will use bar on these 3 digits, because we are here actually a block is repeating itself. Okay, so 657 will repeat itself. That's why its decimals, all type of terminating decimals are rational. All type of terminating decimals are rational. Recurring decimals, here we can find out that if any number is repeating itself or any block is repeating itself, then here these two examples we can see that these are having some pattern. So that's why these are rational. But here when a number is non-terminating or recurring, but we don't find any pattern, these type of the numbers we call them irrational. So here you can see that we find here that this is a terminating decimal, and the terminating decimal, I have told you that all type of the terminating decimals are rational. So that's why this is a rational number. So I hope so that this is clear to you. Now let's move towards the second question. Second question is that convert the following fractions into decimals. Fractions, we are going to convert fractions into decimals. Fractions into decimal fractions. Decimal fractions. So we have here 17 over 25. I will just explain one or two part of it, or 5 over 8. Okay, so this is part number 1 and this is part number 5. Very easy thing that you have to simply divide 17 by 25 and it will also automatically be converted into decimals. So we are dividing 17 by 25. You know that 17 is smaller than 25, so definitely you have to use a decimal point and you will put a 0 here, you will add 0 here, it will become 170. And you know that 25 6 times is 150, so it is 0.6, so 150. You minus it, 7 minus 2 is 7 minus 5 is 2. So again 20 is less than 25, you will add 0 here, and 25 8 times is 200, so 0 is remainder. So it is equal to 0.68. this is, a terminating decimal. Okay, so we have to convert now 5/8 into decimal fraction. So 5 is smaller than 8, put a decimal and add 0, it becomes 50. 8 6s are 48, 2, and add 0, it will become 20, and now 8 2s are 16, 4, add 0 because 4 is less than 8, so we add 0, and 8 5s are 40. So 0 is remainder. Again, it is a terminating decimal, 0.625. So if I call you, ask you that is this a rational number 0.68? Yes, it is a terminating decimal. 0.625, yes, it is a terminating decimal, and 5/8 by definition is rational. 17/25 is by definition rational, although it is not a part of this question, but I am just telling you. Okay, now which of the following statements are true and which are false? 2/3 is an irrational number. Obviously 2/3 is an irrational number. Obviously it's false. Pi is an irrational number. True. 1/9 is terminating fraction. This you have to check that it is terminating or not. 1/9. Let's check. 1/9 is terminating. Terminating means it stop or not. So 1/9, divide 1 by 9. You know that 1 is smaller than, so you have to add 0, put decimal here. So 9 1s are 9. Again remainder is 1. You will add 0. 9 1s are 9. 1. 1 9 1s are 9. You know that 1 is repeating itself, so it is non-terminating or not terminating. So this statement is false because it is written here 1/9 is terminating fraction. 3/4 is terminating fraction. 3/4 is terminating fraction. Yes, it is, because it will stop. 3/4. 3 4, put point, add 0. 4 7s are 28, and 2 is remainder, add 0. 4 5s are 20. So 3/4 is a terminating fraction. So 4/5 is a recurring fraction. This will be wrong because 4/5 is not a recurring fraction because it ends, we get it 0.8 equal to 0.8 because it is 4 and 5. So when you put here point 0, so 5 8s are 40. So it is written it is a recurring fraction. No, false. So it is not recurring or it is terminating fraction. Now we are going to do a very important question, that is that we have to represent the numbers which are given to us on a number line. So it will take a little bit time, so and you will, I hope so, get it easily. So students, we are going to represent these numbers. I have first taken 3 and then I will also show other numbers of this question number 4. So how to show them on a number line, we are going to learn this. You know, okay, let's talk about these numbers first. These numbers, okay, your idea will be clear when I will discuss with you these numbers. This is negative number. On number line, always remember, 0 is the middle number, and to its right side, or on number line on right side, when we move on right side, number, they increase in their value. like 1, 2, 3, okay, and so on. They never stop. And in the same way, if I put here -1, -2 and -3, they when we move towards right side, numbers increase by their value. Like if we talk about -3 and -2, -2 is greater than -3. 0 is greater than all negative numbers. 1 is greater than all numbers which come behind it. Okay, all numbers, it is greater than all numbers. The same way 3 is greater than all these numbers which are behind it. So when we move towards right side on number line, the value of the numbers that increases. Okay, when we move towards left side, the value of numbers decrease. Okay, so that decreases. Now you know that 3 is greater than 2. It means 2 is having less value than 3. In the same way, 1 is less than 2 and 3. 0 is less than 1, 2, 3. -1 is less than 0, 1, 2, 3. -2 is less than. So in this way, these numbers, you know, they have their sense. Like if they are coming on right side, they will be having more value. If they are coming on left side, they have less value. Okay, so now we have this number -4/8, 4/5. I have converted it for my ease into decimal number, and this is 0.8. okay, in value. Like when I convert it into decimal, this is equal to 0.8, negative 0.8. Now you know we have to move from 0 towards -1, not from -1 towards 0, because it is negative number. So we will move from 0 towards -1. There are two ways, because it is not recurring. So there are two ways to draw this number or to show this number on number line. If you use this fraction, and this is the method which is given in your book. If you use this fraction, if you consider this fraction, you have to focus on denominator. Denominator is 5. You will divide this line into 5 equal parts. You are going to divide this line into 5 equal parts. They must be equal. So it is, you know, if I divide it like I have divided it into one part, then 2. You can see that apparently they look same, having the same distance, okay, or same space between 3, 4 and 5. 5 will come on -1. So I have divided this line into 5 equal parts. I am considering this fraction, okay, and you are supposed to do it according to this method. Now 5 equal parts we have divided. Now what is written in numerator? 4. Move from here, 1, 2, 3, 4. It will come here. This is 4, so it will come here, -4/5 at this position. If I call this point P, so you can see that P has come at this position, -4/5. So I hope so that you have understood this. What you are supposed to do, you have to consider first the denominator. In a fraction there are two parts always, numerator and denominator. You are going to consider denominator. Make equal parts according to the value in denominator. Like it is 5, make 5 equal parts. Then consider the numerator. Numerator is 4, so we have to count. So it is 1, 2, 3, 4. So it will come here 4/5. I hope so it's clear. If you consider this, because it is not recurring decimal, so you can also do it in that form. So it was 0 and -1. So here it will be 0, like in negatively 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and 0. So here we get 0 minus 0.8, then we reach to minus 1. So this we can do on graph paper as well, but here you are supposed to do it not on graph. So you use this method, like you consider the denominator first, you make equal parts considering the value in denominator, like 5 is given in denominator, you make 5 equal parts, and then you count the value, like it is 4, so you count from here 1 2 3 4, so minus 4 over 5 will come at this position. So this is the position of minus 4 over 5 on the number line. Now this is 1 whole 3 over 4, it means it is starting from 1. I have less space, so you have to show other numbers as well, like behind it you can show 0, and after 2 you can show 3, but because I am just considering that that much place in which this number will come, okay, so because of the short size of the board. So now it is 1 and it is 1 plus 3 over 5, 1 plus 3 over 5, 1 we have written, okay, 1 is coming here. Now where will 3.5 come in between 1 and 2? So you have to again focus on denominator, that is 4, and what we will do, can you tell me? We will make 4 equal parts. Yes, we will make 4 equal parts, 1 2 3 and 4, 4 equal parts. Now what is the numerator? That is 3. Count from here, 1 2 3. So here we are getting the number, we will write the whole number, 1 whole 3 over 4. So this is the position of 1 whole 3 over 4 on the number line. If we denote it by P, so P will come at this position. So 1 whole 3 over 4, that is the position of the number. And also because this is 7.5, it is again not recurring terminating decimal, you can use it this form, like 1 2, so 1.1 1.2 1.3 1.4 1.5 1.6 1.7 1.8 and 1.9 and 2. You know that 0.75 will come in between 7 and 8. It means it will come here because it is 1.7, this is 1.8, and in between them is the position of 1.75, because that's a half of 1.75 and 1.8. So in this way you can also do, but you are supposed to do in this way. You have to use this method. Now this question is very simple, okay. I will not consider this part because this is recurring, okay. These were terminating decimals, so we can also use decimal form to draw the to show them on the number line, but this cannot be because we cannot find the exact value, exact position if we consider the decimal part. So we have to just consider this part. When you will consider this part, you will get the exact value, exact position where this number will come. So its denominator is 3, and definitely it is coming like it is 0.6, and it will come between 0 and 1. So you have to make 3 equal parts, 1 2 and 3, okay. So now count the value which is given in the numerator, so that is 2, so 1 and 2, so its position is 2 over 3. This is the position of this number, this one. So I hope so that this is clear to you, and I don't consider that there is any confusion. If you are having still any confusion, I can explain you can ask me, you can write it in the comments. Now let's consider the one more example. Now all these type of the examples you can solve by yourself. Now just we consider one number which is in square root, that is square root 5. Okay, before that let's do part number 4. Part number 4, that is 2 wholes minus 2 and 5 over 8, 2 whole number 5 over 8. And after that I will just explain you this square root 5, that is very important. So this number definitely, you know, it is minus 2 whole 5 over 8. So if I convert it into decimal, it can be, because when we divide 5 by 8, 0.0, 8 6 are 48 and 2 0, 8 2s are 16, 4 0, 8 5s are, so it is 0.625. So it means it is minus 2.625. It means it will come in between minus 2 and minus 3. Minus 2 and minus 3. Now it can be written as minus 2 plus minus 5 by 8. 5 by 8. Okay. So what you are going to consider this minus 5 by 8? Obviously you will consider first the denominator. You will make 8 equal parts. So 1 2 3 4 5 6 7 and this would be 8. Okay, 8 equal parts. So here we are having minus 3 at 8th position. So what is the numerator? That is 5 or minus 5. So count here the value minus 5. 1 2 3 4 5. So your number minus 2 whole 5 over 8 will come at this position, if we represent it, or if we denote it by P. So this is the position of minus 2 whole 5 over 8. Now square root 5, how will you represent this or show this number on a number? So students, let's now show, our question is show square root 2 and square root 5 on number line. Because it was only square root 5, but I have also considered this to square root 2 to make it clear to you. Always remember that here we are supposed to use Pythagoras theorem. Pythagoras theorem. Pythagoras theorem, remember, it is always applied on right angle triangle in which one angle is of 90 degree angle, and opposite to this right angle, opposite to this 90 degree angle, we have a side which is called hypotenuse, and any of the other two side becomes perpendicular or base, but here you are always going to keep the vertical side perpendicular and horizontal side as base. This formula says that the square of hypotenuse is equal to square of the base plus the square of the perpendicular. One thing for these type of the questions in which you show irrational number, these are irrational number, and you are going to show them on number line, always remember that perpendicular must always be equal to 1. You can't have, or you don't have any other option. Perpendicular will always be equal to 1. So perpendicular is equal to 1. So now in these are hypotenuse. These both are hypotenuse, and all these type of the numbers, if we are in this like we are having this type of the question, that in which we are going to show the irrational numbers on number line, these irrational numbers always are hypotenuse. So it means that h is equal to square root of 2. So perpendicular we are always keeping 1, and base will also be equal to 1. So when 1 square plus 1 square is equal to 2, so it is hypotenuse square. So we take square root on both sides to cancel this square, and we get square root of 2. So square root of 2 is basically equal to 1 plus 1. So base is 1 and perpendicular is 1. Now first of all we show this base on this line. So it is of 1 centimeter. So you have to, and also remember that in this case, first in previous examples I was taking just that much portion of the number line where the number was supposed to come, okay, but here I am starting it from 0. So in these type of the cases you have to keep two things in mind, that you have to keep perpendicular equals to 1 and center always at 0, center always at 0. Then you have to first show base on this line. So base is equal to 1, so it means it is coming here, and perpendicular is also equal to 1, so 1 unit up means this is 1, so same distance you will move up. So this is when you will draw this triangle, you can see that how I have joined it. So from this I have joined this top to this center, and center is always at 0. So this is 1, this is also 1, this is 1 base, okay, this one is equal to this base, this one is equal to perpendicular, and they both make square root 2. They both make square root 2 because we have seen it through this this all solving. So this is our hypotenuse, okay. So what we are supposed to do now, we have to use compass. You have to put one end at this center and the end with pencil here at this position. You are going to open the compass in this way, that one end at this, one fixed end at this center 0, and the other end which is having pencil, that you are going to put here, and you are going to draw the arc like this. I am not having the compass, so I am showing you like this. So you have to show the you have to draw the arc like this, okay. So when you will draw the arc, definitely it will cut this line at some position, at some point. So that point is actually the position of square root 2, the position of square root 2, okay. So now we show this square root 5 on the number line. So square root 5, first we should have a rough idea about square root 5, that where it will come. So will it come in between 0 and 1, or 1 and 2, or it in between 2 and 3? So rough idea we can get it by, like, you know that 4, after 4 we get 5, and we also get 9, okay. So if we take square root on all these numbers, if we put square root on all these numbers, now you can see that it is coming between 9, square root of 9 and square root of 4. So square root of 4 is 2, and square root of 5 we will keep it as it is, because it is not a perfect square, not having any exact value. So square root of 9 is 3. So it means that this square root of 5 is less than 3 and greater than 2. So it means it will come in between this, it will come here in this part, in between 2 and 3. Now you can see we have to again use Pythagoras theorem for square root 5. Pythagoras theorem, it is square root 5. So square root of 5 is always hypotenuse, as I have told you that it is always hypotenuse. We have to just check, we will keep perpendicular always equal to 1, perpendicular always equal to 1, and this we can check that what will be the value of this. So this will be 2, obviously. How? Hypotenuse square, the formula is hypotenuse square is equal to base square plus perpendicular square. Put these values. Base is, we are going to put 2, and perpendicular we are going to put 1. So 2 2s are 4, and 1 square means 1. So 4 and 1 5. So hypotenuse square is equal to 5. When we take square root upon it, so 2 cancels square root, and h is equal to square root 5. Now first of all we are going to show this base on this number line. So base is equal to 2 centimeters, so it means we are here. Okay, perpendicular is 1 centimeter, so draw 1 centimeter. Okay, and if you use graph paper, it is very easy. Okay, now this is the point. Now join it with it 0, join it with center. This has become right angle triangle. Put one end of the compass here, other end here, and make an arc. Make an arc. Definitely it will cancel this line at some point, and where it cancels this line, that is the position of square root 5. Okay, so this was square root 5. Radius, you know, is same, so this is square root 5, and when we draw it, and we get it its position here. So I hope so that this is clear to you. If you still have any question, if you are not getting anything, you can write that in comments. I will explain you, but I hope so that it is clear, because that's why I have explained 2 examples. Recap of this: perpendicular, these values we always take as hypotenuse. First thing, these values we always take as hypotenuse. Second thing, perpendicular, this vertical line is always 1 centimeter, is always 1 centimeter. Base depends that what is the number, according to that we find the base. And the other thing is, we always take start from 0. This line we start from 0. Okay, always in these cases, like when we are going to show these rational numbers on number line. So I hope so now it's clear to you. The other fifth question, this was question number 4. Fifth question was, 2 questions are given, like given that rational numbers, we have to find the rational number between 3/4 and 5/9. Simple thing, you are going to, because we are going to find out their midpoint, so we will add them. And how do we get midpoint? We always add and divide by 2. So we add them first. 3/4 plus 5/9, add them. This is these both are different. I have made lessons on fractions, you can see them. So these are different denominators. 4 9s are 36, we always multiply them. 4 9s are 36, and 4 9s are, so 9 3s are 27, plus 9 4s are 4 5s are 20, and this is 47/36. Now we have added. What we are supposed to do, we will divide it by 2. This number we will divide by 2, means 47/36 we will divide by 2. So to get the number between them, so 47/36 divided by 2. So 2/1 we can write down and convert it into multiply, take reciprocal. So 47/36 multiply by 1/2. So 47 ones are 47, and 36 twos are 72. So this number 47/72 is the number between 3/4 comma 47/72 comma 5/9. It means that number between these two, or the fraction between these two, is 47/72. Okay, last question is, express the following recurring decimals as the rational number P/Q, where P, Q are integers and Q is not equal to 0. This is by definition of rational numbers, you know. So first part, here I will just do 2 parts, and you can easily understand it how to do. We have to convert these numbers, means this number 0.5, this is a recurring decimal. Recurring decimal means this bar sign actually shows that this is recurring decimal. Okay, so this is part number 1, and we will show it into we have to show it or convert it into P/Q form, means into fraction. And the other part I will do 3. Second part I leave to you, you can do by yourself. and this is the bar is on 0.67 and bar is on 6.7. Here the bar is on 5. We have to convert it into P over Q form, means we will convert it into a fraction. First thing what you are supposed to do here is, first thing which you are going to do here is, you have to let this number equal to x. X is equal to 0.5 and bar upon it. Now you have to remember that what you have actually let equal to x. So you have let 0.5 bar equal to x. Now this 0.5 can be written as, because this is recurring, we can write it as 0.5555 and so on. Now this bar is on one digit. Bar is on one digit. When the bar is on one digit, you are supposed to multiply by 10. 10 having 1 0. Bar on one digit, we multiply it by 10. Okay, 10 is having 1 0. So we will multiply both sides by 10. So we multiply x by 10, so it becomes 10x. And when you multiply this whole number by 10, first I write it, then I multiply 10 by 0.555 to so on. When you will multiply this 10 to this number, it will become 5.5555 so on. So this is 10x equals to 5.55555 and recurring, 5 is recurring. Now what we can write it as, this number can be written as 5 plus 0.5 plus 0.5555 and so on. Now 5 plus 0.5 and bar upon it, because this is repeating itself, so that's why we can write it in this form. This shows that this is recurring decimal. So now this we have actually let equal to x in the beginning. You can see that in the beginning we let 0.5 bar equal to x. So we will write it as 5 plus x, and here we are having 10x. Now what you are supposed to do, you have to further simplify it. Just you shift x to this side, it will become 10x minus x equals to 5, and 10x minus x is equal to 9x equals 5, and x is equal to 5 over 9. So this is the answer of the question. So x is equal to 5 over 9. So here P is equal to 5 and Q is equal to 9. I hope so this is clear to you. If any part is not clear, you can write that in comment. I will answer you. The second part is, here the bar is on a block of 6 7. So it is, what do we do first? We first let it equal to x. So x is equal to 0.67 with bar on it. This is very important thing that you have to remember, that what you have actually let. Okay, so you have let 0.67 bar on it equals to x. So this is very important thing, because this you have to use in the solution which is coming. So when we were having 0.5 bar on one digit, we multiplied by 10. Now here we have bar on two digits, so we will multiply by 100. Yes, if we have bar on three digits, we multiply by 1000. This you can easily memorize. Okay, so if the bar is on one digit, multiply by 10, bar is on two digits, multiply by 100, bar is on three digits, multiply by 1000. So it is bar on two digits. So first of all, we will write it as 0.67, 67, 67, 67, so on. Now multiply both sides by 100. Both sides. When you multiply x by 100, it becomes 100x. And write here 100 into 0.676767 and so on. Now when you will multiply 100 to this number, it will become 67 you can even check it on calculator. So just this decimal, we shift it 2 digits ahead because we are multiplying by 100, so we shift this decimal 2 digits ahead. If we multiply it by 1000, we shift decimal 3 digits ahead. If we multiply by 10,000, we shift decimal 4 digits ahead. This is a rule, so you can even check it on calculator. So it will be 67.676767 and so on. Now this further can be written as 67 plus 0.676767 so on. Now this can be written as 67 plus 0.67 and bar on it. Now you have let this 0.67 in the beginning equal to x. Now just replace this 0.67 bar equals by x. So it will be written as 67 plus x and 100x. Now shift this x to this side, it will become 100x minus x equals to 67. So 100x minus x is equal to 99x, 67, and 67 over 99, that is the value of x, or x is equal to 0.67 bar, or x is equal to 67 over 99. So 67 over 99. So students, I hope so that I have made this exercise clear to you. Try to revise it once again by yourself to understand it in a better way, and if you still find any problem in any part, you can comment, write your problem in comments, or like that is the most appropriate way to talk to me. So I will be answering you all of your if you are having any problem, I will be answering. So thank you so much.